I'm Erik Marks. I'm the Snaps platform team lead, and my corner of the growing MetaMask organization is responsible for building out Snaps. And so for some of you who have followed the development of this may be familiar, but for those of you that have not, Snaps is what we view as the most important feature for the future of MetaMask and for the future of Web3 application development generally. And what it allows you to do is it provides you the means to extend the functionality of MetaMask at runtime without asking us for permission, without asking anyone for permission, except for the user. And so at the moment, we have a canary release, a canary distribution of the MetaMask extension. All of the development of the Snap system is happening on the, it's simply behind a build flag on our main development branch. And here, if you go at metamask.io/flask is where you, as a developer who's interested in these tools, will go and download it. But without further ado, I'm going to basically be heavier on the demonstrating and lower on the talking in this talk to go over some of the capabilities of Snaps. So to start us off, we have been working with Protocol Labs and our good friends at ChainSafe and have partnered with them for some time. And they have developed the first key management snap for our platform. And so a snap is simply a JavaScript program running in a sandboxed environment inside of MetaMask. And it does not get any capabilities by default. And so when I hit connect here, we're going to get a permission request from this dApp that ChainSafe has built to go along with the snap. And we see here that it is identified by this URL-like ID, which is telling us that this snap is a package that lives on NPM. And when we hit connect, we will get a second confirmation, and this is from the snap itself. And so at this point, MetaMask has fetched the snap from NPM, unpacked it, and has read its manifest in order to display this confirmation. And if we click here, for example, we can go to the package listing and confirm that, oh, this thing is a thing that really exists on NPM. And so when we, and that's visible, good. And so we see here the list of permissions, a complete list of the sensitive permissions that this snap wants access to. So it wants to access the internet, display a confirmation in MetaMask, store and manage its data on your device, but also manage our Filecoin and test network keys. And so what these permissions allow, well, we'll ignore the test networks because that's kind of an implementation detail, but focusing on the Filecoin accounts, this permission will give the snap the entropy that it needs, the private key that it needs in order to generate accounts for the Filecoin protocol from the user's secret recovery phrase inside of MetaMask. And so you're basically adding the capability to MetaMask to manage Filecoin keys. And this works with any SLIP44 compatible protocol that uses BIP32 and BIP44 and so on to generate its keys. And when we hit improve and install here, we make sure that the user understands that you're giving key access to this snap. But only to the keys that you see in this list, or for the protocols that you see in this list. And then once that approval goes through in this dApp, we can see that I am rather impoverished on mainnet but have some Filecoin to work with on the test network. And so all of this, this address is a valid Filecoin address, and so is this public key, and all of these were generated with Filecoin Protocol Labs crypto implementations running inside of MetaMask, and I have no idea how they work, frankly, other than that, like they are, other than that, I can send transactions with them and sign messages. And so if I do this and sign, this will sign the message, hello ETH Denver, with my private key inside, run in the snap running inside of MetaMask in order to, and so I can hit approve, and then I get a response back. And so, and that works equally well for transactions, which I won't demo right now, but take my weird Filecoin balance as evidence that we have done so in the past. And more recently, we have been working with some hackers at ETH Denver, pursuing some of our bounties for snaps, and a capability that we will be shipping shortly that we added to the ETH Denver branch of the MetaMask extension is WebAssembly. And so in this particular example, which we'll delve into a little bit further, we will like hit install here as well. And again, we get the permission from the website to let us know that the website wants to have the permission to communicate with and install this snap if it's available. And here we see that the ID is prefixed with local to indicate that it is hosted locally on localhost. It's not published to NPM. And also we have added some tweaks to shorten the developer feedback cycle when you're iterating on your snap to make it easy to reinstall and so forth. And so when we hit connect here, we see that this one also wants to access the internet. And the WASM permission is so new that we haven't added a locale message for it yet. But this permission effectively provides the WebAssembly global, JavaScript global API to the snap. And when we hit approve and install here, we can, let's actually take a look at the source code of this thing. Yes. And so this is, so in this particular example, what I've done is I pre-compiled a very simple WASM program with a single function main that returns the number 42. But I know one of, right, yeah. But we have already tested this with complete Rust crypto libraries, like with the full JavaScript bindings, and that also works. But don't use stdlib because that doesn't work in WASM. And so in this particular snap, so we have the precompiled WASM module here. And so in this environment that the snap is executing in, you'll find few platform APIs. So like you don't have a DOM, you don't have like Node.js API, so you need to bring those yourself with some minor exceptions. And so we expose this wallet object in the Snap global environment, which is analogous to our Ethereum object inside that you get in a dApp. And you can register an RPC message handler with this function. Otherwise, you'll find the API of that object very familiar. And what this function does is it registers a function that allows you to implement a JSON RPC API that can be called by any dApp that has the capability of talking to your snap. So you can effectively arbitrarily extend the MetaMask RPC API using snaps. And so in this case, we have this initialize WASM, which does some, converting the string to a buffer, and then calling webassembly.instantiate in order to actually initialize the module. And then we have the WASM object available to us and can call the methods that are exposed via its interface. And we have simply this one function here, call WASM, and which calls the main function. And if we return to our lovely DApp here and hit call, we see that we indeed get the string 42. And this is in a PR on GitHub, so you can verify that I'm not merely console logging this. And so to see what this looks like inside of MetaMask itself, and so you can see that I'm in MetaMask Flask because of the fancy purple fox. And so if we go into settings here and go to snaps, sneak preview. Whoa, alpha leak. So we can see we have like both the Filecoin snap and the WASM snap inside of MetaMask, and we can go and we can drill down and see like what permissions they have, which sites they're connected to, and we can also remove them from this page. We can also see that they can be enabled and disabled, which prevents sites, any site from starting the snap and communicating with it. And we can also see their status here, which is, in this case, the Filecoin snap is running because the web page is talking to it, but the WASM snap is stopped because we want snaps to have a AWS Lambda or service worker life cycle where they spin up to do their job and spin back down. So they need to be able to stop and start gracefully. And in order to be able to have the persistence model for snaps is that they get there is that permission that the Filecoin snap has, which basically gives it a key in our state and a JSON store where it can put whatever data it wants. And let's see, how much time do I have? Yeah, ish. And so, in essence, we have been working on snaps for some time now, and are really excited to have it in production and in front of more developers. MetaMask is hiring, the snaps team is hiring, and we, as I said, have bounties here at ETH Denver. We view this as fundamental to the future of how MetaMask will grow and encompass more protocols, more layer 2s, more assets, and more features for the future. I thank you all for your time, and I'm happy to answer any questions.